So if I derivative the term, it's R1 x0. Okay? And minus M0 x minus A minus 1. Okay? Then minus P x minus A 0 order. Okay? And minus Q0 x minus B first order. Okay. So that means if you want to solve the differential equation like this way, if you want to use shear to solve the equation, your shear force, the connection with external loading will be like this, right? Then for the Q loading minus Q, Q loading, okay, Q loading is equal to EI. Okay, we say minus Q loading is EI is minus EI. Minus EI. Minus EI. Okay, W force. So this equation is a response to minus EI. So just further derivative about this one will be R1 x minus 0 minus 1 and the plus M0 x minus A minus 2 and minus P x minus A minus 1, okay, and minus Q 0 x minus B 0. Okay, so you can see the dimension of this Q should be the same, this Q, and this is 0 order. Dimension should be matched. Okay, should be matched. So that's why I just show you the derivative and the integration about this half-range function. Okay, so that's the purpose. So instead of sometime maybe the moment, for example, okay, if some loading, discontinued loading, is very complicated, okay, maybe something like this, whatever, okay, you have to find the resultant moment and the location of this loading to get the moment, like very difficult. So instead of doing this, we prefer to solve the loading directly by Q and solve the fourth order equation. Okay, so sometimes I think from this way is easy. So what I want to say is, for this kind of a loading, in moment, okay, let me do this. So in this, if you want, in the future, if you want to solve this equation, or we say the Qx will be minus R1 x minus 0 minus 1 minus M0 x minus A minus 2 plus P x minus A minus 1 and the plus Q 0 x minus B 0. Okay. So that means in the future, if your reaction force, because in Q loading, this concentrated force with respect to the order of x minus 1 order and downward, it's downward concentrated force. So it's so this R1 is upward, so it's minus sign. For the P loading here, it's downward. It's x minus 1. So concentrated force, which if you want to write Q, should with a -1 order. Okay, for concentrated moment, this one we apply is counterclockwise. As okay, so we say this is clockwise will be positive. So here, that one is counterclockwise. We use a minus, but its order is x minus a d minus 2 for concentrated moment. For distributed loading Q, downward positive. Okay, it's downward Q. And with x minus b, emphasize 0. Okay, so order for loading Q, 0. For moment, -2. Okay, for concentrate P, -1. So in the future, if we directly use this equation, and you should write this force directly, but be careful. R is with the dimension, the concentrate force with dimension -1. For concentrate -2. Uniform loading, distributed loading is 0. Okay. For the moment, you can see, for the moment, the dimension R should go with a x minus the first power. Okay, just like a P. Okay. The moment minus P. And the Q is minus Q. But here is more straightforward. Okay. See what I mean? Okay. If you want to solve this equation, it's okay. If you can write out the moment relation, it's one way. Okay. But for the Q loading, for the Q distribution effect with half range function doing this way. Q. Okay. Right. So this is for concentrated point force. This will be -1. And it's concentrated moment is -2. And for the distributed force, it will be 0. For the Q, it's matching the dimension of the Q loading. So this just from the example you can see this correspondency, the older dimension correspondency. Yeah. Right? Here is a plus moment, but this is for -Q. So if for positive Q, it will be -0 here. Okay. But this case, it is clockwise. So in the future, this is positive sense, positive moment, positive Q. So these are positive. Okay, moments clockwise for Q is positive. Okay, but dimension should with a -2, power of -2. Right. So I want to give you some example about how to write this kind of discontinuous loading. For example, this case. Q0. And this is for x equal to A. And this is x equal to B. Okay. And this loading is equivalent to this one plus this one. All right? For this discontinuous loading, okay, then this one you can write as a Q0 x minus A. Q minus A for Q loading is 0. Right? Q is for 0. And subtract Q0 x minus B. 0. Okay? Then for triangle loading, okay, and this is equal to what? Equal to, for example, this is x equal to A, x equal to B. So first thing we can write down is square x equal to A, x equal to B, this one, and subtract. No. It's equal to, it's better to write this way. Just extend. So this loading extend and subtract the loading here. All right. If you discontinue it. So it's very complicated. Okay? You have to write out how to treat this kind of function. Yeah, let's try. Maybe we do this triangle first. For example, this is x equal to A. And this is x equal to L. So this function will be what? The Q loading, and this is Q0. So Q0 as x okay. So this Q0, this loading is say what? L minus A. X minus A divided by L minus A.